like I said before during this, if there's any questions while he's going through this, just please stop him and have him explain it or re-show it to you.
Yeah, if the camera view is not coming through clear with some of the lighting, definitely I'll zoom in as much as possible. And again, what we'll basically do is kind of go through like the initial startup with the reagents prime, run a calibration. We'll watch the cycle happen just so we know kind of how the analyzer works. And then I'll go through the screens a little bit again. Obviously, we just went through that in the presentation, but see the more relevant screens during operation. And then I'll go through the tubing replacements and taking apart the pumps and getting access to the tubings. And then if there's anything you guys want to see, more closely, we'll certainly show that. So now we're in front of the analyzer. The first thing we'll look at is kind of on the side here. So that's the fast loop reservoir that has our sample come into. So again, on the bottom side here, this will be the tubing that goes to our analyzer. And that's where the analyzer will draw its sample from. Kind of on the top here, this will be our connection to the analyzer. So once we plug this in, we'll get our flow alarm should there be no flow to the analyzer. Right now I just have it disconnected because we don't have a live flow in our conference room here, so we would trigger the alarm and not be able to run calibration like we want to. So we open up our analyzer here. Again, we can see up top we have our electronics, just power switch, and then again our terminal block for any of 4-20s, alarms that we want to connect up. And then at the bottom here, we have all of our pumps and other components. So again, selection block. This tube here on the number 1 port is going to be for your sample line going to that fast loop reservoir. And then in the case of the copper analyzer, our port number 2 would be going into our calibration standard below the analyzer. Again, the monochloramine won't have that cal tubing. It'll really just have your tubing right to your sample pump for your inlet. And a little bit closer look at our flow cell block here. Again, cap right here, overflow tubing, reagent tubings down to our pumps. Again, copper will have all 3 of these pumps. The monochloramine will only have 2. This little screw here is just a thumb screw that just holds the flow cell in place. And then here's our LED. And at the end of this, I'll take this block off, and we'll see inside we have the mixing pump, the detector board on the back side, and there's also a small heater, which again isn't super hot, so this block will just be a little bit warm to the touch. That just helps catalyze our reaction, make sure our reaction doesn't take too long, especially in the case if our sample was a little bit on the cooler side. Then on the bottom here, we have our drain pinch valve. You can manually kind of activate this valve. If we watch our sample volume in our flow cell, if I just push this in, our sample is going to drain out the bottom of the flow cell. Just manually can empty that cell should we have to for any reason. Just see how that process works. So if I back out a little bit, we'll see on the bottom we've got our reagent bottles, and again the bottles for the analyzer for the copper might look a little different. I believe the volumes might only be 2 liters. These are 2.5 liter bottles, but the process will be the same. Again, when you get your new reagents, discard the old stuff, put the new stuff in place, and then you'll get some caps that come with the analyzer that will have a little hole and a grommet on top. We'll just install the new bottle. And then our reagent struts here that connect to our reagent pumps are numbered R1, R2, R3, and just match them up to the various pump. And put that into the reagent that it goes to. Then all the way on the right, we have the calibration standard. Again, on copper, we'll have that, which comes up into the side of the analyzer, into our number 2 port on the selection block. And the monochloramine, again, won't have that. Always a good idea anytime you change your reagents, kind of date code the reagent once they're opened. The shelf life on the reagents not only has a closed shelf life, but then kind of once you open them, usually they start to kind of react with air a little bit. So it's always a good idea to know when you open them, just in case you end up in an extended shutdown or an offline period of time. The reagents don't sit for too long. It just could cause cal failures and bad readings and things like that. So once we have the reagents, tubing's installed, we'll want to prime our reagents. So if we come to our So if we look at our screen, again, we've got our second option is going to be this display button. So once we press display, again, we get a lot of these numbers, our sensor value, our reference, our reading. But what we're looking for is this manual commands button over here on the right. That's going to bring up this drop-down menu here. And we'll scroll down and we'll look for add reagent 1. And once we find that and select that, change our timing to 60 seconds. And once I hit this, I'm going to press on. You should hear our reagent pump start to activate. And once our reagent pump's turning and starting to draw in our reagent, we're basically going to be looking for reagent at this flow cell cap to start dropping into our flow cell. That's just an indication that we've got our reagent primed and we're ready to go. There it is. Again, a 60-second time is enough to not only flush out anything that might be in there, but to make sure we get our reagent from the top to the bottom of our tube. So once number 1 is done, we'll do the same thing for reagent number 2. Then once number 2 is done, do the same thing for number 3. Alright, so now all 3 of our reagents are primed. One thing we would do if we were doing our monthly reagent replacement we would want to come to our main screen. And then our reagent counters along the bottom, should say, right now they say 99, 100, and 100. Again, first startup they should all be probably at 100, but any monthly reagent replacement we'll have to reset them back up to 100. So in order to do that, we'll just tap on the number. This little screen will ask us, reagent 1 bottle filled. Pressing the X, we'll say, we didn't refill it, we just hit it by accident. And then if we hit the S button, that number will go back to 100%. So we would do that for all 3 reagents. Again, on the copper, all 3, the monochloramine will only have 2. It'll still show reagent 3 and 4 there, but again, those numbers should never move from 100% because there's no reagent pump attached to those values. So now that we've got our reagents primed, basically we're ready to do a calibration now before we get online. So to initiate calibration, from our main run menu, and here we've got our few options. I will hit this extra cycle. So once I hit extra, we'll hear the drain valve start to go. See auto function down at the bottom corner here. And now we're going to go through our calibration process. So we see our sample pump rotating now, it's drawing in sample. Basically it's going to first rinse out the flow cell with whatever was in there from the last time. And again, this process we're going through now is the same for analysis cycle online or calibration. The only difference being in the calibration, our selection block has our calibration setting selected. Online, our selection block would have our sample selected. So again, at the beginning, we do a rinse out. We basically see this flow cell fill up with sample 2 full times and then drain out. Be the first drain, it'll fill up again a second time, drain out, and then the third time that it fills up will be the sample volume that we use for a reaction. So once that third flow cell fill happens, we're kind of done with the sample pump until the end and rinse out, and that volume is the sample that we're going to use for our analysis. So say we were to lose flow online after this point now, the analyzer will continue to finish this cycle. It knows, hey, I had enough sample to start, my flow cell's filled, we can go ahead and finish the sample, and then at the end of the next one, we'll go to stand by once we get sample back. So once we fill up the flow cell this time, we'll start adding our reagent. So again, this timing and the reagent timing, the mixing timing is all going to be a little different based on the chemistry of the copper, the monochloramine. Watch this focus here, we'll have our first reagent, similar to the copper. In the case of the monochloramine, both reagents actually get added at the same exact time. So you see both reagent 1 and reagent 2 being added. And then also the timing of the reference and reading commands can be a little bit different. Right now we have a mix time, so our sample pump is just mixing. I'm just going to drop this down a little bit just so we can see, hey, this is our mixing pump circulating everything in the flow cell back from the bottom up to the top. And we'll take a look back at our menu screen to kind of see from our display menu what's going on here. So again, we've got the sensor value is kind of the only number right now that's moving around. And this graph is just kind of plotting that sensor value as things happen. These big spikes here are our sample flow cell filling and emptying. When it empties, that number goes way down because it only has air in the cell, and then as it fills up with sample, it should be around 8.5 or 9. And again, this number is what becomes the reference and the reading numbers when the analyzer knows that it's at the right time to take those numbers. So the exact number of this what the sensor says or the exact reference number isn't necessarily as critical as the difference between the reference and the reading numbers for each measured cycle. So right now we got a minute or two of mixed time. Before it'll actually add reagent 2, and then we'll have another mix for about a minute, and then we'll see the reference number should update with whatever the sensor value is reading at that particular time. And then the main thing that we're going to be looking for on this screen is once we add our third reagent, our color reagent, we should see a big drop in the sensor value. We should see a nice drop on the graph, basically indicating that, hey, there's silica present in the sample, it's forming color, and again, that's what we're trying to measure. So obviously the benefits of calibration are you make sure your analyzer is accurate, but also most problems where we're not adding reagent tend to cause readings of 0. So this gives you a good chance to say, hey, let's validate, make sure everything's working, getting added correctly. Obviously, if we go through a calibration, we don't see any color. We know that there's something wrong probably. But again, when the analyzer calculates its calibration factor, it's programmed to know, what a good factor and what's a bad factor. And anything outside that bad factor range just says, hey, again, something's totally not right, and let's take a look at what could be wrong. So we should be coming up on the end of this mixed time right now. Again, the whole sample time is a little different for each analyzer, but it's about a 10-11 minute process of rinsing, mixing, and you get your result kind of near the end of that 10 minutes. And then there's a little bit of wait time added to each cycle. So you're looking at about 20 minutes in between readings, and again, that gives you about a month's life of reagent usage. So now we can probably hear and see that number 2 reagent is being added. Again, I want to have about another minute of mix before we update our reference value. Again, that's our before reading. Again, if there was any dirt building up on the flow cell or a little bit of turbidity in the water, that would all be taken into account at this stage. This is kind of like our start point, our 0 point. Any color that's in the sample at this point, we're assuming is not related to our reaction that we're looking for.
And I would think for the analyzers you guys have, that the blank really won't come in play. I mean,
no, it won't for those two. No. Just a brief wait period, just to make sure that the mixed up sample is any air bubbles that have formed might be coming out, and get a good stable reading. You see that we got a new reference value. Now we're adding reagent 3. I'll try to get in a little bit closer. So we should start seeing the sensor value drop down, both on the graph and the number itself. And basically that's our reagent reacting with any silicon in the water. And again, we'll be doing the same thing with the monochloramine and the copper. Again, this will mix for about another minute. And then at the end of that time, we'll take our reading, snapshot of our sensor value. And then the reading and the reference are used to calculate that absorbance, which will update. And then the analyzer will calculate a new cal factor. So we can see we got our new reading number, calculated its absorbance. Now we're going to start to drain and basically do that flush process again. We'll flush out everything that's in the flow cell. Sample pump is going to fill up and drain three times in that flow cell. Then the analyzer will be in standby, ready for either another analysis or to go online. Any questions on the calibration process or the analysis cycle itself? So now that we've finished our calibration, if we wanted to check what our actual calibration factor was that we calculated, we would need to log in with the password. So there's two password levels. We have a service password and an admin password. The service password is in the manual, and it's 4 ones. The admin password is not printed in the manual, but the password itself is 6699, and if you need it for any reason, we're certainly willing to give it out. But you do get access to a few things that could certainly affect your overall performance of your analyzer, so you just have to be a little careful when you use that password to not change anything important. But when we log in, we get this calibration screen. So again, it shows our new factor that we just calculated, 1462, I think. And again, if our calibration factor was outside the range that the analyzer considers good, this screen would be flashing. You also have a calibration failure alarm on the main screen. And again, it doesn't mean you can't run the analyzer. It would continue to run with the last good cal factor that it had. But you can't get rid of that alarm message unless you do successfully pass a calibration. So if we were in our startup point and we just calibrated and primed our reagents and we're go back online, we would come back to our main screen. And we would go to our run menu, and then again we have our couple options right here. This top option is start online. So once I press that button, we can hear our analyzer start to work. We get a little online notification down here in green. And then if we were to go back to our run menu, we can see that the text on our top start online button has disappeared, meaning we're online. And we've also grayed out our channel 1, so that means we can't start a single cycle right now. If I were to tap where it used to say start online again, we can see that the text came back. And basically what that means is now the analyzer is going to finish the cycle that it's on and then go into standby mode. So we were getting ready to do a reagent replacement or something like that, or maintenance. we would let it finish, and then we could go ahead and take the analyzer offline. If we didn't really care what the reading was on right now, we just said, hey, we're ready to do our maintenance, we could certainly come into the run menu and hit this emergency stop button. So that just stops the analyzer in whatever it's doing, mid-cycle. We do get an alarm that pops up for a fault, just saying, hey, you stopped the analyzer for some reason. And that way, if you had that alarm, wired into your DCS or something like that, you get a notification that somebody stopped the alarm and the analyzer and it's offline. Before we can do any kind of command, whether it's calibration or manual command or start back online, we just have to come back to our run menu, hit this reset button, which will clear that alarm, and then say, hey, you acknowledge that you stopped the analyzer, and now it's ready to go back online and take measurements or do whatever you need it to do. I will show real quick, when you log in with the admin password, this service menu that you get access to. The main reason that you might need to come into this screen would be for this full scale number right here in the middle. And then obviously is the full scale of the analyzer, but what that also is tied to is your scaling for your 4 to 20 output. So your 4 is always 0, and then your 20 milliamps equal to whatever you put into this field. In this case, it's set to 100. Default would be the full scale of the analyzer, which in the case of the copper is probably 100, and I believe the disinfectants analyzer is 5 ppm. So changing that again only changes your scaling on your 20 milliamps. You don't have to worry about it throwing off anything with this calibration or the true range of the analyzer really. Again, just for your output. Your output scaling for that. Also of note on this screen, on the right-hand side, we have our various relays. Again, there's 4 relays you could put a wiring to. Not sure how well it's coming through on the camera, but if you press on that, you'll cycle through the various options you have for that relay. Again, they can be result alarm, power on, loss of flow. So again, if you need to wire any of that for alarm notifications, you can wire them and then set which alarm you want to be related to that relay right there. There is also kind of a hidden screen. If we press next to the X, again, even more things that could certainly affect the analyzer. The main one on this screen that I would like to show is over here on the left-hand side. We have a backlight delay minute. Default's usually about 30 minutes, and what that is just kind of like a screensaver on your touch screen. So after 30 minutes of not touching the screen would go into kind of turn itself off and go all black. Kind of save the life of the touch screen. But obviously, what we've found more often happens is people walk by the analyzer and assume that it's powered off. So if you're don't want to see that, and you always want to see the screen online to assume that your analyzer is running and see your reading, you set that number to 0, and that way your screen will always be on. And worrying about the screen burning out doesn't really seem to be an issue. Again, we've had a couple of these that have been installed now for over 10 years and hadn't had to replace any screens due to the backlight burning out or anything like that. So again, if you put the analyzer on, walk away from it, and then you come back a few minutes later and it looks like it's off, could just be the backlight timer. All right, so I think that's about all I have for putting the analyzer online, going through the menus. If there's any questions, I'll answer them now. The next thing I'll do is kind of go through our tubing replacements and how to change the tubings for the quarterly maintenance cycles. All right, very good. so again, with these tubings, again, we kind of recommend quarterly, based on running all the time. And, supplied with the analyzer or extra is this tubing kit, which basically comes with all the tubing that you need for a full year's replacement. So it'll come with 4 drain tubings, 4 sample pump tubings, enough reagent pump tubings to do all the reagent pumps 4 times a year. And then also the extra tubings like the sample lines, these mixing tubings that, again, don't have to be replaced as frequently because they're not under any compression and being worn. It's more just, cosmetic. If they start to get dirty, replacing kind of look. So again, the first one that I'll go through is the flow cell drain tubing replacement. So that's this one down here. So again, to take that one off, the best way to do it is really take out the flow cell itself, and that way you can clean out the flow cell at the same time. It's always a good idea to do that. In order to do that, the first thing we'll want to do is take off the flow cell cap, and again, just inspect it for any kind of dirt building up on these tubes. Clean it with a Q-tip, paper towel, anything like that. Again, shouldn't be anything, but it's always a good idea to check for some things. And then we'll want to disconnect the mixing loop tubings at the top and the bottom. Now it's very important to note that the flow cell has these inlet and outlet nipples on the top and the bottom. That's probably the most likely thing to break as you're taking this flow cell in and out. There is a groove cut in this block to rotate the flow cell when we pull it out. But before we pull it out, it's still in place. We have to release our drain tubing. So on the bottom of the analyzer is just a tube fitting, which is tied to the overflow drain vent. So we can pull the tubing up through the bottom of the analyzer, and then we just need to release it from this pinch valve. So in order to do that, we can just kind of manually push in this valve, and then just kind of push our tubing out of the way and release it. So now we have our flow cell loose. We can hit this little thumb screw that just holds our flow cell in place, rotate it, and pull it out. So again, here, now that we have the flow cell out, clean it with a cotton swab, Kim wipe, no lint paper towel. Obviously, we don't want to scratch this. Fingerprints will definitely throw off our readings. And again, if there's any buildup on the inside, we can certainly wipe that off. Then actually just take the tubing off, just twist it off, grab the new one that should be cut to about the right length out of the kit, and twist that back into place. And again, wipe our cell one more time if we got any fingerprints on it, and then we can slide it back in place. Again, this is probably the most likely time that you break one of the inlet and outlets on it. The first thing I usually do when putting it back in is attach these mixing loop tubes just to give us a little cushion on those pieces should they bang against the flow cell block. So now we got our flow cell back in place. We kind of got to push our tube for our drain back in by manually pressing in the drain valve and then sliding the tube in place. Again, after it's in place, kind of do a little up and down just to make sure that tubing isn't twisted. If it's twisted, it might not pinch closed properly, and then you'll end up with a situation where your flow cell won't retain any of the sample and it will just drain out while you're trying to fill and mix, and obviously end up with bad readings. Then we just back to the bottom of the analyzer, reconnect to our drain overflow tube, and then put our flow cell cap back in place. Again, take a little bit of care. It's not a super tight fit, but again, anytime you're putting an O-ring into a glass cell, there's obviously a chance it could break should you use too much force or it doesn't go in neatly. And we just finger tighten our flow cell back into place, just so it doesn't get knocked around too much from vibrations or anything like that. And then that's basically our flow cell tubing. Once we do the sample tubing, we'll run a sample pump cycle just to make sure that the tubing's in place right, and that we did the drain valve tubing correctly, and that it's holding sample in the way it needs to. So for the sample pump tubing, The kit comes with this little sample pump tool, which is handy. Not required, but makes it a much easier process. First thing we can do is loosen our 4 screws on the pump head and take them out. Then once we pull off that pump head, we'll see that the front side has an inverted groove, and then the back side actually has this groove sticking out, which is what mates with the pump motor on the back side of the panel. So we'll just have to make sure that when we put it back, we get that right. As far as these 2 plastic halves of the pump head, they're identical. So once we take off the tubing from the selection block and then the mixing loop, we can take the whole thing and just take the 2 halves apart. Again, these plastic halves are identical, so you don't have to worry about that, but we can see that the rollers, does have to go in one way. So once we pull out the tubing, you might be able to see a little bit, and this one's been in operation for a little bit, starting to flatten out a little bit. Again, this is normal after, maybe a couple weeks worth of runtime. What you might see after the quarterly stuff is a little bit more wear. Some of the tubing starting to break off and kind of form a debris on the inside of this pump head. And you just wipe it clean. Again, obviously, if you see any kind of leakage or tubing breaking all the way through, you'd want to say, hey, maybe we got to do this replacement a little bit more frequent so we don't end up in that situation. Then as far as getting the tube back in place, we grab the new tube that's cut to the right length. And this is where this tool comes in handy. Again, if we don't have this tool, it does come in the consumable kit. But if you don't have it, you're lost or whatever, you can kind of just force the tubing into place by rotating it around with your fingers, and we'd be okay. But again, the tool makes it easier. Once we get one end, kind of hold one end of the tubing in place at the inlet, and then this tool slides into place kind of between the rollers and then against the pump head. Then as we rotate, it forces the tubing against the rollers and then into the pump head body. Once we get that, we can line up our inlet and our outlet again. And then once we add our other half of the pump head, just kind of press it together again. Just make sure we don't pinch the tubing, inlet, outlet. And once we've got that together, line up our groove for our motor back in place. Make sure we got the right amount of tubing on both sides, and then put our screws back in place. Yeah, once these are finger tight, we don't have to tighten them too much. Finger tight, and then a quarter or a half turn or so is all you really need. And then just reconnect our tubing at both ends, and then that part would be complete. So at this point, I always like to do a check. Just run a manual command on our sample pump. Just draw and sample, make sure the tubing's in place properly, the pump's in place properly, and also double check that we did our drain tubing correctly as well. So if we come to our main screen, we would go into our display menu, same as we did for our reagent prime, hit the manual button. And then on this drop-down list, there's various commands, one of them being add sample. I'm going to add sample for about 25 seconds, and then hit on. And then now we should see sample pump turning. Should be drawing in sample into our flow cell. So good indication that we did the sample pump tubing placement correctly and everything's working well. So then once that flow cell fills up, is where we can get a good indication that we did our drain tubing correctly as well. If we just watch this level in this flow cell for a few seconds and that level stays constant, most likely we did a good job. If we see that level in that flow cell is slowly draining even with the valve not activated, just might mean we have a little twist in the tubing. It just needs to make a better connection, better mating with that pinch mechanism. So we can just, usually wiggle that tubing in place a little bit more and usually just straighten out. So the last part of the quarterly tubing maintenance will be our reagent pumps. So the nice thing about peristaltic pumps is that none of your reagents are in contact with really any pump components other than the tubing. You usually get a better lifespan out of your pumps. Obviously, a little more maintenance intensive, but again, once we have the tubing replaced, that's the only thing in contact with some of the reagents that can be a little hazardous and corrosive at times. So the consumable kit also comes with a small Allen key that is the right size for the screws on the front of this peristaltic pump. So we can start by loosening and removing these 3 screws. And once we have this cover off, and you set that aside, it's a good idea to inspect for any leaks, any excessive dirt buildup. Or obviously, if we have moisture on the inside of the pump, we'll want to dry that out. And then we just need to look to see if it came from a leak or actual wear through of the tubing. But once we have the cover off, we can kind of pull the tubing off, and what will probably happen is the rollers will come out with the tubing. That's okay because we need to get them out anyway too. So you can take them out and set them aside. And once we have this tubing out, we can disconnect both ends. And then obviously, take a quick look at this again. See this one's starting to get a little, flattened out. Again, that's totally normal. We grab the new tubing, which should be already cut to the right length, and also has new fittings on both ends from the kit. Each end is a different size barb fitting. The smaller one goes up to the top for the tube that leads to the flow cell, and then the slightly larger one goes to the straw at the bottom to the reagent bottle. So I like to connect the new tubing first, and then put the tubing into the pump head before, as opposed to connecting the tubes afterwards, because my fingers don't really fit kind of between these valves, or the pumps rather. So once we kind of have it connected, kind of slide it through the openings in the pump head. And again, we'll just make sure that it's in and the curve of the tube matches the pump head. We don't want too much slack inside or it be too tight, put a little bit too much resistance on the pump motor. And now we got to get our pump rollers back in place. So your kit will also come with a replacement set of rollers. They're plastic, so they'll wear a little bit over time. Again, there's enough for kind of once a year replacing these rollers. It's always a good idea to inspect them, but they shouldn't see any excessive wear until you get to about a year's worth of runtime. So to get these rollers back into place, we should see on our pump we've kind of got we've got our 3 roller places. There should be about one open one that we can slide that pump onto easily. And then we'll want to come back to our main screen where we have our manual commands list. And we'll pick the same one that we would use for a prime. So we go to add reagent 1, just do it for 1 second, and then hit on. And when I hit on, you'll see that roller should kind of rotate into place, and we should free up the next roller's position. So for 1 second, now we've got next roller position, put that roller into place, and then do the same thing again. 1 second, and get the last roller into place there. And again, we'll just make sure that our tubing's not sticking out from the pump head too far, get pinched when we put the cover back on. So now we can just put the cover back on and screw it into place. again, don't have to be overly tight. The cover's only plastic. If you tighten too much, it could crack. But again, once that's in place, we'll have to go back and we'll do a reagents prime for 60 seconds to make sure our reagent is primed through all these tubes. So it's a good idea to line this up with a reagent replacement, since you're going to have to prime your reagent lines anyway. Then it's always a good idea to run a cal after you do this too. Make sure everything's working correctly, and make sure that analyzers can be accurate when it goes back online. So that's all the quarterly tubing replacements. Any questions on that, or want to see any of them again or closer? Yeah, the procedures are in the manual, but obviously written down. Doesn't always make as much sense as seeing it, but hopefully having seen it, step by step, follow it when it comes time in a few months. So kind of the last thing that I want to do is take the flow cell block out and just show you kind of behind the flow cell, should you have to get access to maybe replace a mixing pump or something of that nature.
Yeah, and this is the benefit of doing this virtual training is these things that Kenny's doing right now, you would not get this on a field startup and training, because we're there to start the equipment and make sure everybody knows how to use it. So this is I think definitely an added bonus for anybody that has been utilizing these services during this unprecedented time.
All right, so in order to gain access to this flow cell block, I'm going to basically take this panel out of place. First thing I want to do, I just want to drain any sample that's in the flow cell, just so it doesn't leak all over me. And then there's 6 screws in the plate that we can remove. So now with the panel loose, we'll just have to disconnect this tube here, pull out our flow cell cap, loosen the vent tubing so we can free up that space. Just kind of slide this forward and out. So what we can see now is kind of behind our flow cell block. So here we can see this little metal piece here is our heater. Again, not super hot, just hot enough to make sure our reaction happens. Behind the heater is our photodetector board. So this board here is just on the back side of that flow cell, just receiving the light. On the front side of that, there's a little lens. Again, that's just looking for the color shown through by the LED to detect any changes in that. And then right here we have our mixing pump, little diaphragm pump. To remove that, we would loosen the screws on the front side first, and then pull it out the back, and then replace with the new one. All these components back here just have these little quick disconnect connectors for the electrical side of it, so they're nice and easy to remove. And again, the only other thing going on behind the panel is these connections and the pump motors on the other side. So no sample should be back there. Cause any problems. So with that, I mean, that's kind of the whole analyzer. Any questions, any clarification? Yeah, really anything we talked about, or maybe I didn't talk about? Mm-hmm. Mm-hmm. Yeah, absolutely. I mean, it definitely would help. Um, Again, all that buildup, for the most part, should be cosmetic. One thing you would look for it to start affecting your readings is actually in the data logger. We see kind of on the right hand side, it kind of tracks our reference numbers. So that reference number should be fairly constant and stable throughout our readings as we're going through time. But if you're starting to see over the course of a few days or a few weeks, that number may be dropping from around 9, maybe into the mid 8s, and then down to maybe even the high 7s, that's an indication that your flow cell is actually starting to accumulate some dirt or film of some kind. And that's really where you would start to see, maybe some effects. Again, because it does a start and the reference each time, you won't necessarily shouldn't see too much effect from that. But obviously, eventually, you would get to the point where not enough color is getting through the cell at all. Obviously, will affect your resolution and your accuracy a little bit. Yeah, we certainly have a bunch of analyzers that have. I think we've got 50 micron filters that we've supplied for a few analyzers that certainly can help keep some of the dirt out of your sample. No, it's good to think about. I mean, again, hopefully it's just cosmetic buildup for the most part, and but the filtering certainly would help. And yeah, it's not uncommon to have filtering before they are.
Yeah, and our plan would be, obviously, just because of COVID restrictions, we're doing this virtually, but our plan would be eventually when things start to get back to, somewhat of a normality, we probably would would at least look or offer to, you know, then fly out and do an on-site and just sort of revisit this and do it in person. But, you know, we wanted to make sure we at least got you off and running today, so